Let's talk about the sign integer division. So we were using the iDIV instruction. So this iDIV instruction will be similar to the div instruction. We still have the divisor in the operand. So then your dividend still will have in the AX or DX AX combined and EDX EAX combined. But before, when we do the unsigned integer division, we can just copy over the value in DX. Sometimes if your dividend is only in AX, so we just need simply to make our DX copy over the 0. But that's because we do the unsigned integer. But when we do the signed integer, if we want to have your, for example, this one is AL. So, but your dividend should be in AL and AH, right? So then here, actually, we cannot just simply to copy all the 0 in the AH to fill out the upper half in the dividend. Instead, actually, we need to be the sign extension. So that's why when we do the sign integer division, so your sign integer extended, they need to be the before the division take place. So that's why your higher byte or word or double word, actually they are a copy of the lower byte, the sign extension. So how should we do that? So that's why here we have 3 instructions. They will provide you the importance for the sign extension operation. So when you do the CBW, they will convert the byte to the word. So extend the AL sign integer sign bit into the AH. So CWD change the word to double word. So they will extend the sign bit to the DX. So the same as the CDQ, we will have the DX. O will be the sign extension from the the EAX. So how to do that is similar like this. So when we want to do the 32-bit operand division, so for example, we want to have our EAX value is this one, 101. So we can see here your EAX value for 101 is good enough to save. But one thing is when we do the iDIV, they will still consider the EAX, the EDX value. So that's why here, this EDX value, you need to make sure they will have the sign. So 1 byte, 2 bytes, 3 bytes, 4 bytes to be the sign extension. So you will call the CDQ before you do the iDIV instruction. So we will see this one, for example, for our iDIV sign division. So I want you to use the 8-bit division for the operand. So we're using the -48 divided by 5. Right, so 5, we can just make that copy over to BL. So then when I try to using the 8-bit, we will combine the value is in AX, right? So then here you can do 2 different ways. You can do the -48, just copy over to AX. So they will right away have their extension. Or just make that -48 copy over to AL. So you call CBW. So they will extend the sign bit equal to AH. So your iDIV instruction after you done your quotient and the remainder, they are all the same in this AL and AH. So this one is for the 8-bit division. So you kind of say, I don't really need the CBW. I can just copy over -48 to AX. But then if we work on in the 16-bit version, then you really cannot copy over to the DX. So that's why here when we're using the 16-bit version, so then your 5 will move to BX. So then your dividend need to combine with your dx and ax. So I can copy over negative 48 to ax, but we don't know how to do the dx. So instead you manually to copy over, we can just call CWD. So then they will extend the sign bit into the dx. The same thing, your result, still your dividend, your quotient is in ax, so your remainder is in dx. So the same thing for the 32-bit version, we're using the EBX for the operand, but the EAX, we copy over the value with the negative 48. So we call CDQ, so that's why the EDX will have the extension. So the quotient will save in EAX, then the remainder is in EDX. So let's try this example. We move the AX is FDFF. So then we have BX is 100. So on the other hand, we are trying to do the 16-bit operand. So that's why you have this CWD to extend your bit extension, sign bit extension into the DX. So do you know what is the value? Will we have the divide overflow happen or not? Yeah, so that's your result. So then actually we don't have the dividend overflow happen because we try to divide 100. But one thing is you can try, if you try to divide by 10, then you may have your overflow happen. So that's our sign division.